All right, we're up to lesson 10 of unit 7. There's no new lesson notes today, so we're going to go right into the examples for lesson 10. So let's take a look here. Your math teacher gave you and a partner a bag with paper slips inside of it that are marked either pass or fail. Okay. You draw 10 slips at random and notate how many are marked pass and the proportion of the 10 drawn that are passed. So in other words, they pick 10, they mark how many are marked pass, and then the proportion is another word for a percentage. So the percentage of the 10 that are passed. You then put the 10 slips back in the bag, mix it up, and repeat the process. You keep doing this until you have a total of 5 trials. The results of your 5 trials are shown below. You then combine your data with the data from the rest of the class and get the following dot plots. So this one right here. Number 1, estimate the mean proportion of slips marked pass based on the dot plot. So this is roughly a symmetrical dot plot. So this is roughly symmetrical. Because it's symmetrical, the mean is going to be where the high point is. So if I change the color, the high point is obviously here. So estimate the proportion. So this is 0.6. Okay. This is 0.8. In the middle would be 0.7. So the mean proportion of slips marked passed based on the dot plot would be approximately 0.7. The standard deviation is approximately marked 0.1361. What is the approximate margin of error that should be attached to the mean estimate? So to do that, what we're going to do is we're actually going to go back and look at the notes from lesson 9. So let me pull up the notes from lesson 9. Okay. And if we go and look at this, you'll see the margin of error. To calculate the margin of error, it's going to be 2 times the standard deviation. 2 times the standard deviation. So in this case, that's going to be 2 times 0.1361. So I'm going to take a calculator. I'm going to use my phone, and I'm going to calculate that. 2 times 0.1361 is 0.2722. That would be the approximate margin of error attached to that. Okay, so the estimation of the mean is 0.7, and the standard deviation is the margin of error is 0.2722. Okay, so that's number 1 and number 2. Let's take a look at number 3 now. A biologist is breeding fruit flies to include a specific genetic mutation that will be useful in understanding memory in humans. To check whether a fly has the mutation, a DNA sequence is analyzed in a way that kills the fly. So the biologist only wants to test a sample of flies to estimate the proportion of flies that have the mutation. The biologist selects 40 flies to sequence at random and finds that 9 of them have the genetic mutation. Estimate the proportion of flies that have the genetic mutation. So that we said that 9 out of 40 have the genetic mutation. So the estimate is going to be 9 divided by 40, which, according to my calculator, is 0.225. Okay. Number 4, assume that the standard deviation is 0.06. What is the approximate margin of error? We're going to do the same thing we did on the last set of problems. So based on our notes from the previous lesson, my margin of error, I'm going to abbreviate that MOE, is 2 times the standard deviation, 2 times SD. So in this case, it's going to be 2 times 0.06, okay, 2 times 0.06. That will give me the approximate margin of error, so that will be 0.12. So my margin of error is approximately 0.12. That is the last example. That is it for lesson 10.